this article by Sharon Griffin called Teaching Number Sense. Sharon Griffin is a developmental psychologist and has done some absolutely amazing things with early numeracy. And this was the definition that drove it home for me. She said that the discipline of mathematics comprises three worlds. So the first of which is the actual quantities that exist in time and space. So the quantities that I was able to find this morning are batteries. So these are things that I can hold on to, that I can touch, that I can feel in time and space, right? They're right here. This represents a quantity of something. This is mathematics in my hand right here. The next world of mathematics is language. Language is absolutely crucial in mathematics. I think a lot of times we underestimate the role of language, and we tend to think of it as this nonverbal, purely quantitative arithmetic kind of way. But think about this. 1, 2, 3, 4. I've just used language to describe the quantity of this set. And I can even think about how much this would shift. Because I can say that this is 4 batteries. And you think about 4 in a very particular way. As though I'm describing the unit, the quantity. Let's say if we're talking about measurement and I say 4. Is 4 big or is 4 small? What do we think? It depends on the unit, right? The language is so critically important. Am I talking about 4 grams or am I talking about 4 tons? There's a big difference in my interpretation of the quantity. So language is the second world that we're connecting with mathematics. The third is, I can describe this with a numeral that looks like this. That's a symbol. It's a numeral that represents the quantity in my hand. And so the way that Sharon Griffin described it is that number sense is kids who have really strong, rich relationships between the worlds of quantity, the language used to describe that quantity, and the relative size of that quantity, which we refer to as magnitude, and then the symbols that we use to basically do the record keeping. And so these are the things. This is the heart and essence of mathematics, and this is why we like these measures. Because when we go through these measures, what you will see is that we are measuring the development of these relationships. And I want to say something, that these measures, they are simply proxies for a kid's development of these relationships. There's nothing magical about the way that we're measuring. There's nothing that we should just take this task and immediately make it an instructional task, because that's not what important. That's not what is important about these measures. What's important is that we're looking at and thinking about and measuring how a kid's making connections between quantity, language, and symbol. And we'll go very deep into that with each measure and talk about which of these connections this particular measure is a proxy for. And so that was Sharon Griffin's description of it, and it just so happens that our neuropsychologist friends are finding the exact same thing. So Stanislaus Dehaene has done all of the work around number sense in the neuropsychology field, done lots of work with folks who have brain lesions and the kinds of math they're able to do with the specific lesions that they have, and he describes it in the exact same way. We have different ways that we code and process mathematics. The first of that is a quantitative magnitude code. It's a very rudimentary processing. Think if you had 5 dog biscuits and put them here, and 1 dog biscuit and put it here. Where would your dog go more frequently? The pile that had 5. Your dog, there's no indication that your dog can actually count. There is some indication that they have some rudimentary sense of quantity. That kind of is based on how big the set is at a very basic level, and that's where it starts. But as it becomes more sophisticated, we as human beings have used language and our use of language to make it much more complex, and we can define it in a much more precise way. And we'll talk about that as we get into some of the measures of what's kind of the fundamental basis for that. It turns out that it's the number line, is how we process quantity and magnitude. And then finally, once we start to define quantity with language, we've developed symbols and abstractions to write with mathematics and to do incredibly complex things with quantity that exceed our mind's basic capacity to understand. The early numeracy assessment has to explicitly measure these relationships between quantity, language, and symbols, but more importantly, that then the instruction needs to go to building those relationships. It can't be rote and procedural. We always have to think about measuring or connecting instruction back to quantity. It's critically important. So, here's an example of one of the measures. This measure is called matching quantity to number. The directions that's given to the student is here are some dots, here are some numbers. Point to the number that tells us how many. Given what we just talked about as we define number sense, what are the three worlds that we're connecting with number sense? Quantity, language, symbols. What are the relationships that we're connecting with this particular measure? Quantity and symbol, right? We have this set of quantity presented as a visual representation of 4 dots. We're asking kids connect that to the numeral 4. This is a number recognition task. This is a task that has been around for a very long period of time. What we know in kindergarten is that it happens to be a pretty good predictor of later mathematics achievement. What worlds are we connecting when we ask kids to simply name the numbers? Language and symbol. What we decided is that we would never, even though this is the measure that, based on some of our psychometric data, should be given first at kindergarten and first grade. And we don't have any problem with that measure, but what we would say is that this measure should never be given without also the previous measure that's connecting quantity to number as well. Because what we don't want to have happen is because we assess what we value, it's flashcards going up of numerals and just asking kids to name it. Why? Because there's no connection back to the quantity. Remember, the real math lives here. Yeah, we might see some increase on this particular measure at this particular point in time, but this does nothing for the underlying math that we're trying to develop in the kid. So we want to ensure, by the way, we sequence the measures and show the measures, that instruction always goes back to quantity, because that's what is important. One more example is called part whole. We say, this is a number 4. It tells us how many dots there are altogether. There are 3 dots right here, so how many dots should go right here? What worlds are we connecting? And then what the student does is verbally gives us the number of dots that should go in that box. What worlds are we connecting with that task? Quantity, language, and symbols, right? So we're making all of the connections there with that particular measure. So as we've just shown some examples, we're clearly going to go much more in depth into all of them. Are you seeing what we mean when we say early numeracy and number sense and how it's reflected in the measures? Awesome. And remember, I've said this already, it's the relationships that are predictive and that we measure. It's not the tasks of the assessment. So simply replicating these tasks and turning them into instructional materials is not going to lead to the achievement that we want in kids. These are a proxy for the development of the relationships. The instruction needs to be rich and rigorous and full of opportunity to engage in these 3 worlds of math.